Hello everyone. Today I'm going to talk about classifying documents to multiple readability levels by Wejdan, Alkaldi and Professor Diana Inkpen from University of Ottawa. We will go through introduction, background, then explain the methodology. Then we will swing through our work, the data preparation and the system implementation. Then we will discuss the results, and finally we will conclude with our conclusion. For the introduction, the ultimate goal of writing a text is to communicate, and written text must be readable and understandable to its targeted audience. Readers who struggle to read the text will build a strong negative feelings toward readings in the future. So finding the suitable text is important to encourage readers to read more often. Studies prove that children who read for enjoyment every day have a better educational performance. They develop a broader vocabulary, increase general knowledge, and build a better understanding of other cultures. Every text has a readability level that helps to decide if the text is suitable for a certain readers or not. The level of a text must match the level of the audience so they can understand the message behind it. And many formulas were put together to measure the readability of a text, like Flesch and Kincaid, Gunning, Fogg, Smog, and others. And there are models also found to categorize the text using machine learning methods. For the background, readability level. Matrix were developed to measure the readability level, and they use the number of sentences, words, syllables to determine how easy a given text is to comprehend. One of the most popular matrices used in school systems are Flesch and Kincaid and Gunning-Fogg index. That's why we will use those two matrices in our work. In machine learning, on the other hand, many features determine the readability level of a text, including logical operation and textual and syntactic information. Classification in machine learning. Random forests and SVM are used. CNN, on the other hand, achieve better results than random forest and SVM in many NLP tasks, especially when using linguistic features. For the previous classifiers, many models were developed to classify documents based on their readability levels using machine learning methods. Like Scarton and others in 2018, they used sentences from Nucella corpus to perform basic machine learning text classification. Classify sentences into two categories only, complex and simple, without specifying the level of simplicity. For Stanger and Udden in 2017, they classified documents into 5 levels based on their simplicity. They used basic machine learning classifiers only, like SVM and random forest. For Yackel and others in 2019, they classified documents into students' grades, from grade 2 to grade 12. They used too many classes over a few number of documents, which resulted in poor performance. For Nucella corpus, Nucella is a corpus of news articles professionally simplified into several versions, and documents have readability levels ranging from level 0 to 5, and they're targeting students' grades from grade 2 to 12. And the levels, level 1 represent the first level of simplification, and level 4 represent the most readable version of the text. For the methodology of our work, in this work, we intend to use 5 categories to label the documents with level 0 to level 4. And SVM and random forest will be used as our base machine learning models. CNN will represent the deep learning model since it outperformed multi-layer perceptron MLP. For SVM classifier, works well with multiple labels and few features. It performs poorly with overlapping classes, but in our work, we don't have overlapping in our classes. It uses two main parameters, gamma, which represent the spread of the decision region, and C, that represent the penalty of misclassification. For random forest classifier, it's good for a data set with multiple labels, and it uses decision tree as a base algorithm, and it identifies the importance of features and give them a rank. For CNN classifier, works well with text classification. It consists of several layers, convolution layer, fully connected layer, pooling layer, and usually convolution and pooling layers are used repeatedly in the model. For the readability matrix, Flush and Kincaid use an equation that uses the length of sentences in terms of words and the length of words in terms of syllabus. Similar in Gunning-Fogg index equation, they're using the length of word in terms of words, and they use the number of foggy words are the complex words in the text. For text classification by readability, the goal of this work is to classify documents into 5 different categories based on their readability levels. We extracted the features and used several models to classify the documents. We used machine learning models for the classification, SVM and random forest, and the results were compared with deep learning classification model CNN. For the data preparation, we used a new Nucella corpus that has English and Spanish documents classified into 6 categories initially. There are over 10,000 documents in this corpus, but we only going to use the English documents, over 9,600 documents, since the number of the Spanish documents are not big enough to train our model. Also, for the categories, there are 6 categories used from 0 to level 5. But we decided to join the categories level 4 and level 5 under level 4 label. And that is because if we see the distribution of the documents here from level 0 to level 5, clearly level 5 has imbalanced distribution. It has only 42 documents in this corpus. And since these documents, the 42 documents, are covering only grade 2, we decided to join it with a level 4, since level 4 also covers level or grade 2 documents. Also it covers grade 2 and 3. But since they cover the same grade number, we decided to join them together to solve the imbalanced distribution. For the data pre-processing, we substituted the multiple lines in the single lines with one, and we removed the non-ASCII codes and the special characters, and we converted all letters to lowercase letters. Then we extracted the features from the resulted data. We use several types of features: basic features, syntactic feature, and common readability features. The basic features include words and textual information, like counting the number of nouns, adjective, verbs. And the syntactic feature use linguistic tools and external resources, like finding the passive voice sentences or the negation in the sentences. And for the readability matrix, they're also used as part of the features. The features of interest in this work are divided into three groups: Flushing-Kincaid as one group, Gunning-Fogg as the second group, and the third group contains the basic and syntactic features, or as we call them here, extracted features. The data are split into 80% for training and 20% for testing. The results are showing in tenfold cross-validation and separately on test data. For system implementation, we used RBF kernel in SVM since it performs well with multiple labels and small number of features. And we tuned the values of gamma and C by applying grid search to find the best value for those two parameters. For the random forest, we set the maximum depth to 8 to allow pruning and avoid overfitting. For the deep learning models, the accuracy of applying MLP classifier and CNN model were 67.91 and 76.90 respectively. So we favored CNN over MLP for that reason. And CNN model used 3 convolution layer, 2 pooling layer, 1 flat layer, and 1 dense layer. And the last layer used softmax for activation. We used batch size of 10, and the epoch were 30. We set 10% of the training data as validation. Here we can see the accuracy values of using CNN classifier, and there is no overfitting in our results. For the results, here we can see the results of our classical machine learning classifiers. We gave the accuracy to measure the results, and we can see here using only Flushing-Kincaid gave us the lowest accuracy result, while after we combine all 3 results, we found the accuracy increased. So it's better to combine all 3 features together to get a better accuracy result. And to show if the confused classes were adjacent or far apart, we calculated the root mean square error. And we can see here that combining all 3 features gave us the lowest RMSE, which is still a little above 0.5 for both classifiers, SVM and random forest. For deep learning classifier, on the other hand, as we mentioned previously, CNN gave us, for accuracy, over 76%. However, MLP gave us only 67.9. So we used CNN over MLP for that reason. And we can see here the confusion matrix for test data using CNN. To compare all classifiers together, in this table, we can see that CNN outperformed all the classifiers. It gave us better classification accuracy, 76, better than SVM and random forest. However, in RMSE values, we can see that CNN and random forest have the same value, a little above 5.5. To justify our results, why did we get this accuracy only? We checked the confusion matrix for the test data, and we found that there are many documents mistakenly assigned to adjacent classes, like here in 82 documents were confused between level 1 and level 2. So looking at the dataset, Nucella, each readability level folder has number of documents belong to certain grades. The assignment of those documents were done manually by professionals, as mentioned in the corpus description. The manual assignment did not prevent the overlapping between readability levels. As we can see here in this table, the distribution of those documents, we can see some documents have overlapping between the levels. Some of the grades documents are not big enough to train our model to distinguish between the levels. Like in grade 8 documents, 14 documents were assigned to level 0 and 43 documents were assigned to level 2. And 43 and 14 are not big enough to train the model to distinguish between level 0, 1, and 2. The number of all these documents is more than 9,000 documents. So to solve this issue, we decided for every grade, we choose the group that has enough number of documents to train the model. The documents here highlighted were chosen based on that, and the number of those documents is above 8,000 documents, which is enough to train our model. By applying the classifiers classification using our classifier CNN, SVM, and random forest, using the new version of the dataset, we can see here the accuracy is much better. The CNN gave us, like before, 82%, while the RMSE values decreased to less than 0.5 for both CNN and random forest. For the conclusion, this paper, we presented experimental results for classifying text documents into 5 readability levels from 0 to 4. The features used include textual information, syntactic information, and the common readability matrix. So using all 3 types of features led to the best results. And random forest and SVM were used as a classical machine learning models, and CNN represents the deep learning model. And the results of CNN outperformed the 2 other models. Also, the distribution of the documents in the dataset, we found it affects the results of the classification. Using a smaller dataset with better distribution sometimes increase the model performance. So an improved version of the dataset was proposed on which it's possible to obtain a higher accuracy. Thank you very much for listening.